Hello, in this video we are going to study about output characteristics of transducer. The output characteristics are influenced by mainly three factors. First one is type of output, second one is output impedance, third one is useful range. The output characteristics depends on the type of electrical output. Just like the input characteristics, they depends upon the input measuring. That is, output characteristics depends on the type of electrical output which we are getting from the transducer. Now the output of the transducer, it can be a voltage or current or maybe a function of any quantity, that is function of voltage, current or impedance. So the output quantity should be the other stages of the instrumentation system. As we said earlier, in a measurement system, we are not only having the transducer, but there are also some other components present in that. Now, these components should compatible with the output of the transducer. The electrical output which the transducer is producing, that should be acceptable by the other stages of measurement system so that they can work over it. So in type of electrical output, we can say that the output of the transducer may be a voltage, current or impedance, or it may be a function of these parameters. The quantity may not be acceptable to later stages of instrumentation system. Their magnitude have to be changed or they have to manipulated or change in their format by signal conditioning. So signal conditioning is selected based upon the output requirement. The type of electrical output affect the output characteristics of the transducer, that what type of the output the transducer is generating or producing. Now the second one is output impedance. The Z0 determines the extent to which the subsequent stages of instrumentation is loaded. Their output impedance are main when we are considering the loading effect. In loading effect, we also studied the output impedance of transducer should be very low. And if the Z is equal to 0, no loading effects are there. But always some loading effects are present there. So when we are expressing the output impedance, it determines the quantity of power force extracted from the input quantity. So ideally in a system, the output impedance is low and input impedance is high to avoid the loading effect. A transducer acts as a constant voltage source if the output impedance is lower and the input impedance is high. And the transducer acts as a constant current source if the output impedance is higher than the input impedance. And when the input impedance is equal to the output impedance, the maximum power transfer taking place from input to output. That is called maximum power transfer theorem. So you can see that how the impedance is affecting the characteristics of transducer. In some case, the transducer acts as a current source and in other case, it acts as a voltage source. So the output impedance is very low. Output impedance is very much important when we are considering the loading effect of the transducer. Now, the last one is output range. As we studied in input characteristics, the operating range is useful range of the transducer is working. It has an upper limit and a lower limit. The upper limit is decided by the transducer capabilities, while the lower range is normally determined by the transducer error or the unavoidable noise originating in the transducer. Basically, the output range, if the transducer it is very low. Hence, here these are not allowed to drive the system due to low signal, low noise and distortion. So, here to increase the operating range, Here the output operating range is limited by noise which can damage the input signal. To overcome such problem, the transducer has inbuilt with an amplifier at the output, which will strengthen the signal level. So that will increase the output range. So these are the mainly three characteristics that affecting the output output characteristics. That is, first one is type of output and output impedance. Third one is operating range. Thank you.